Hi, this is Mrs. Slater, and in lesson 5.7 we are going to solve equations by factoring. So the first thing we need to discuss is the zero product property. This property states that a product is zero if and only if at least one of the factors is zero. So this will end up helping us solve equations and solve for x. So after you write that down, there's a few examples that you do not have to write down, so you can put your pencil down for just a little bit. And I just want to give you a heads up to what zero product property means. Okay, so this is saying that we need to have a product of zero. So the answer would be zero right here. Okay, what value here in this first blank is going to give you zero? Well, it's just going to have to be zero times anything is going to be zero. Okay, so then that leads to algebra, where what if we have an unknown and we need our answer to be zero? In this case, again, our blank would have to be filled in with zero in order to get zero. Okay, and the next part, now I want to look at product. And you're going to see things like this a lot in this section because we are factoring. X minus 2 times what is going to give me 0? And again, the answer is 0. And finally, another one. It doesn't matter what order it's in. If you had the first one to be 0, you're going to get 0 as an answer. No matter what the expression is, no matter if it's a variable, no matter if it's a number. You have to have one of those to be 0. Okay, so now let's begin writing a couple of examples. So the first example is x plus 4 times the quantity of x minus 2, and that equals 0. So we have to figure out what are the values of x that are going to give you 0. So how you can use the zero product property is by setting the first one equal to 0, because in this case, if there's a 0 there, 0 times anything will give you 0. So one of the values of x could be negative 4. The other value of x, we're going to take the x minus 2 and set it equal to 0. So in this case, x is going to equal 2. Now I know that if I check my answer, I will know for sure that I'm correct. So if I plug in a negative 4 in for x and leave everything else alone, this quantity is 0, and this is x minus 2, and anything times 0 is 0. So that is a good one. The other one, if we check, it'd be x plus 4 and 2 minus 2. I'm just taking this value and plugged it in, and I took the negative 4 and plugged it in here, equals 0. X plus 4 doesn't change, but 2 minus 2 is 0, and 0 times anything is 0. So that, again, checks. I know that I did them correctly. Okay, now let's use factoring as part of the examples. So this would be example number 2, and if we had x squared minus 3x minus 28 equals 0. This is a continuation of factoring, and then the new stuff today, which is zero product property. So what we're going to do is set up our parentheses and find the factors of 28 that are going to give us negative 3. Okay, x and x is split. 28's factors are 7 and 4, and the only way I can get a negative 3 is if I put a negative and a positive on the 4, a negative on the 7 and a positive on the 4. Okay, now is when the zero product comes in. So factor everything, and then once you have factored, you are going to set them both equal to 0. So it would look something like this, and then when you solve for x, two answers would be negative 4 and also 7. So those would be your final answers for the values of x. All right, the third one, I would like you to push pause and solve this one. X squared plus 10x plus 25. Okay, so let's check your answer. And factors of 25 that will give you 10 are 5 and 5. And the only way I can get a positive 10 is if I use positives for the middle. Okay, so you set this one equal to 0. You get x equals -5. And you set this one equal to 0 and get the exact same thing. So for a final answer, you do not need to circle them both. It would only be the one of them for the final answer. All right, example number 4. Sometimes you've got to be careful with the way it is written. So for example, this one is not, you can't use the zero product property because it's not equal to 0. So that would be our first step. Always set equal to 0, so then we can find the values of x. So we're going to bring the 6x over, and I'm going to purposely put it in between so I have my trinomial in decreasing order. Factor, so then x minus 4 and x minus 2 would multiply to give a positive 8 and then also add to give you -6, and then use the zero product property. X minus 4 equals 0 and x minus 2 equals 0 for final answers of 4 and 2. Before we go on to number 5, I want to show you how you can check your answer. For example, you go way back to the original, so it would be 4 squared plus 8 equals 6 times 4. So that's 16 plus 8. This is 24. And since we have a match to both sides, we know that 4 is a correct answer. Same thing with 2. If I take 2 and plug it in everywhere I see an x, I get 4 plus 8 on the left side. And then because they both equal 12, I know that that one also works. Okay, so there's always a way to check your answer. Number 5, I'm going to write down 20 plus x squared equals a -x. I would like you to have that solved for class tomorrow. The next examples we are going to have are going to be using GCF. All right, so number 6, I believe we are on, and we're starting with 8x squared minus 16x equals 0. So as you recall, anytime you have to factor, you should always look for the GCF first. Then from there, the 2 terms, then you look for 3 terms, and then you look for 4 terms. Okay, and when you have 2 terms, remember you would look for a difference of 2 squares, and I'm going to do a lot of abbreviating here. Difference of 2 cubes, or the sum of 2 cubes, and then those can factor as well. 3 terms, you can just have a trinomial that has a coefficient that is less or that equals 0, so those are pretty nice to do, or the ones that are greater than 0, which makes it a little more difficult. A trinomial coefficient is what I'm trying to put there. And then the last one, the 4 terms, you're either going to group a 2 and 2 grouping, or it's going to be a 3 and 1 grouping. Okay, so those again should be going through your mind. Always, always, always get that GCF first before you begin, which is what these examples are all about. So I can see that there's an 8x in common on both of them, so I'm going to factor those out, and what's left over would be x minus 2. So with the zero product property, notice that 8x is multiplied by the x minus 2. So I'm going to do the exact same thing as before. It's just going to look a little different because I'm setting 8x equal to 0. And this one does not look different because it's a binomial. And I'm going to set that one equal to 0 as well. So after I divide both sides by 8, I get x equals 0. And I add 2 to both sides, I get x equals 2. So those are going to be my 2 answers. Okay, so let's go on to the next one. If I gave you 9x squared plus 27x equals 0. We first would look for the GCF, and since 9x is a GCF, what's left over is x plus 3. And zero product property says that one of them has to be 0, so we're going to set them both equal to 0. And we end up with the two answers of 0 and negative 3. So what ends up happening is, if you have a variable that is a GCF, you are going to get 0 as an answer. Okay, and you can always check your work. Now, this last example I want you to have ready for tomorrow in class. And here it is. 5x squared equals 35x. Don't forget to set equal to 0 first. Alright, example number 9. With GCF, there also is some situations where you will not have a variable that will be able to take out. For example, as you can see on this example, 3 is in common, and we're left with x squared minus 9. And with zero product property, we would set, actually we haven't factored everything first. Make sure you factor everything. This right here is difference of two squares. So we can say 3, always carry that factor down, x minus 3, and then x plus 3 will equal 0. And then by zero product property, all 3 of them would be equal to 0. Okay, so when you have set the first one equal to 0, you'll notice that there is no variable. So that is not going to help us solve anything for x. So we would basically just get rid of that. We don't need it. This one would be 3, and this one would be negative 3. And there's our final answer, and then also called solutions. So if it ever asks you to solve, that is what we're looking for. 2 answers that will work for x. Now let's move on to difference of two squares. Okay, we've already just did an example problem of that. So there's 2 ways that this could happen. For example, you may see difference of two squares in 2 forms. One could already be set equal to 0, and the other one could be just set equal to a specific number. In the first one, since it's already set equal to 0, and it's difference of 2 squares, we can go right to the factors. X minus 6, x plus 6, for answers of 6 and negative 6. So those would be our solutions. Now another method that you might remember is if they are separated by the equal sign, we can take the square root of both sides. And when we do that, we always have to remember taking the square root of both sides is going to lead to 2 answers, the plus or minus. So you can pick which way that you would like the best. So with the last couple minutes here, let's recap of what we did to solve the equations by factoring. The first thing we have to do is set equal to 0. The second thing, list the terms in descending order. The third, you're going to factor by GCF, and maybe a combination of 2 terms, 3 terms, 4 terms. This one I'm going to save for another assignment, but the 2 that you need to be, or the 3 you need to be aware of are GCF, 2 terms and 3 terms. And then fourth, you're going to use the zero product property. And then your 5th term, you can always check your answers to see if you are correct by plugging into the original. Okay, so now let's end with a couple of jokes. So what do you get if you divide the circumference of a pumpkin by its diameter? Pumpkin pie is the answer. And what do you call a pig that does karate? A pork chop. And here is Pork Chop from Toy Story. I figured that would go well. Pork chop. And this concludes the lesson for today.